Now let's talk about the velocity triangle of the impulse turbine. So here I have drawn the velocity triangle of the impulse turbine. So let's see what are the different things. The first line, this is called V1 and it is the actual velocity. It is the actual velocity of the fluid. Now there, due to the velocity of the moving blood, that is u, there is an relative velocity. So this velocity Vr1 is the relative velocity of fluid with respect to this blade. The blade shown here is also moving, so there is a relative velocity. Now since the blade is moving in the horizontal direction towards the positive x-axis, the velocity of blade is shown in here. This is the velocity of the moving blade, and this is called flow velocity Vf1, and it is called flow velocity. Now this whole part is called wheel velocity of the fluid, that is the turning velocity of the fluid, wheel velocity. Now we have to also note the angles created. The angle created by the actual velocity of fluid is alpha 1, and the angle created by the relative velocity is beta 1, and this is the inlet velocity triangle of the fluid. Now let's talk about the outlet velocity triangle, and note that, and this is very important concept that is often not told, that this line this line this line is tangent. This line is tangent to this blade, because for the maximum efficiency gain, the fluid velocity must be tangent to the moving blade. So note that this is tangent. Okay, and similarly when coming out of the blade comes tangentially, so this is not b2, this is actually Vr2, relative velocity with respect to moving blade. So if the blade is in this direction, then the actual velocity will be less than this. So actual velocity is V2. And note that the angle made by relative velocity is called beta 2. And note this beta 1 used for relative velocity at inlet, and beta 2 used for relative velocity at outlet. And similarly B2, and it is called alpha 2. Now the flow velocity, this Vf2 is the flow velocity, and this part only, note that it is the part of the actual velocity. This part is called Vwt, this is the wheel velocity. And what is this remaining? This remaining is the u, and it is the velocity of the moving blade. In this way the velocity triangle is being completed. Now here we make the combined velocity triangle. So you can notice that V1 is coming downwards, so I am making V1 like this. V1 is coming downwards, and the BR1 has greater angle than V1, so I am making like this, and then perpendicular line like this and this. And this is the inlet velocity triangle, and I'm adding the outlet velocity triangle on the same diagram, so I'm making with it a different color. Now here you can see the combined velocity diagram. Now note that this part is B1 actual velocity, BR1 and perpendicular BF1 and BW1 and it is U. And note that when creating the outer velocity triangle, look, this BR1 and BR2 is connected, so make a line from this. And you may question why make line from this is make the common U, that this part U is used in the both velocity triangle. So we are creating BR2 starting from BR1. So start from BR1 and B2. For the B2 U has to be subtracted. So create B2 in these directions, and in this way the combined velocity diagram is completed. Now in the impulse turbine, in impulse turbine you have to notice that Br1 equals to Br2. But why is that? You have to always remember Br1 equals to Br2. It happens because of Bernoulli's theorem. So you may see that inlet pressure equals to outlet pressure. Okay, the pressure is same, and the jet height, inlet equals to jet out, so potential energy also same, so the relative velocity should also be same. So the relative velocity with respect to turbine should also be same, so Vr1 equals to Vr2. One conceptual idea of thinking why is Vr1 equals to Vr2 can be like this. Like this, take this the rotating blade and fluid enters tangentially, look, and goes tangentially, and always being tangential to the surface. You at any point it is tangential, so you have to notice that the force is always perpendicular. Look, at any point you may notice that force is always perpendicular, so force does not do any work on the steam. So inlet velocity equals to outlet velocity.